let's have a look at the atom. So first of all, I'd like to have a look at our model of the structure of the atom. So there are two main parts to the structure of the atom. First of all, we've got what's called a nucleus, and that's contained within the centre of the atom. And this makes up 99.95 or thereabouts % mass of the atom. It also is about 1/10,000th of the diameter of the atom. The other important thing about the nucleus is that it's fixed for all chemical and physical processes. If there's anything we want to do to the nucleus, it has to be a nuclear process. And finally, the nucleus contains protons and neutrons. We've also got a second part to our atom structure, and that's what we call the electron cloud. Now, by contrast, this has very small mass, so 0.05% of the total mass of the atom, but it actually defines the diameter, or what's more commonly known as the radius of the atom. And the radius of the atom will change according to the number of electrons within that electron cloud. So we can change the number of electrons, or we can change what the electron cloud functions and looks like by changing the number of electrons in that cloud. Now, there are three fundamental particles. There are many more particles that make up an atom, but we're only going to deal with the three fundamental particles. So we've got electrons, as we mentioned before. They exist within the electron cloud. They're given the symbol small e, sometimes written as an E with a minus on there to denote a charge. They have a relative mass of 1/2000. We're comparing this with the mass of a hydrogen atom. So 1/2000th of the mass of a hydrogen atom, and they have a relative charge of -1 compared to a neutral zero charge. So in other words, they're negatively charged. We've also got our second particle, which is called a proton. We denote with a little p, sometimes known with a p with a plus on it, to denote that this has a positive charge. The relative mass compared to a hydrogen atom is 1. The relative charge compared to a neutral charge is +1. So we see that we've got our two particles here with a positive and negative charge on them. Our neutron is our third particle, denoted with a small n, sometimes with an n and a 0 on it. Has a relative mass compared to a hydrogen atom of 1, so the same mass as our proton, and it has a neutral charge. So this gives us a more accurate picture of what happens within the atom if we use those fundamental particles. So within the nucleus we have our protons and neutrons. Within our electron cloud we have our electrons.